Hello everyone, this is Abhin Solanki from S&D College of Engineering Research Center, Yola. Now today we will discuss the numerical problems of the Unit 2, that is on the basis of chopper circuit. So let us take first numerical problem, that will be it is given by problem that a chopper is operating on TRC, that means time ratio control, at frequency of 2 kilohertz on a 460 volt supply. If load voltage is 350 volt, calculate the conduction period of thyristor in each cycle. So one by one, step by step, we will do that. The solution where V is equals to is given by a data is given, that is 460 volt, VDC that is the 350 volt, frequency that is the 2 kilohertz, and chopping period that is T is equals to 1 by F. Now we can find out the value of chopping period T, put the value of frequency, we'll getting the 0.5 millisecond. Now we put this value in this output voltage formula, that is the VDC equals to T on upon capital T into V. Conduction period of thyristor is T on is equals to capital T into VDC upon V. Now put this value in this formula and we are getting the T on time, that is the 0.38 millisecond. In that numerical problem, we should have to calculate the conduction period of the thyristor in each cycle. So this is the conduction period T on, that means conduction period at the on time of the thyristor. Now second problem is that the input to the step of chopper is 200 volt and the output required is 600 volt. If the conducting time of thyristor is 200 microsecond, compute chopping frequency. If the pulse width is Hall for constant frequency of operation, find the new output voltage. Okay. Now we will give the solution. This is the V is equals to 200 volt. T on time is equals to 200 microsecond. And VDC is equals to 600 volt. So according to the formula, V of DC is equals to capital V into T upon T minus T on. So we will put the value of this parameter and get the VDC, or we can say that in that VDC is also given, so we should have to find out the capital T. So T is equals to 300 microsecond. Now we will find out the chopping frequency. The chopping frequency F is equals to 1 by T. So F is equals to 1 upon 300 into 10 to the power minus 6, that is equals to 3.33 kilohertz. And pulse width is Hall, that means T on is equals to 200 into 10 to the minus 6 upon 2 is equals to 100 second. Frequency is constant, F is equals to 3.33 kilohertz and T is equals to 1 upon F, that is equals to 300 microsecond. So therefore output voltage is equals to B upon V into T upon T minus T on. So that will be output voltage is equals to 300 volt. Okay, so this is the calculation and solution of this numerical. According to that, we can find out the value of the output voltage. Now next numerical, that is the third problem. In that you can see here what is the problem. First we read out that the problem is given that DC chopper has a resistive load of 20 ohm and input voltage Vs is equals to 220 volt. Condition is that when chopper is on, its voltage drop is 1.5 volt and chopping frequency is 10 kilohertz. If the duty cycle is 80%, determine the average output voltage and the chopper on time. So in that, what we'll find out? In that, we should have to find out the average output voltage and chopper on time. So as it is, data is given that source voltage 220 volt, resistance 20 ohm, frequency 10 kilohertz, and duty cycle, that is T on upon T, is equals to, that is the 0.80. Now in that we can see here the VCS voltage drop across 0.5 volt. Now we will put the value in average output voltage and find